Hello everyone and welcome back to Hyperlyceum. I am Shadia Ayati, your narrator, and in this tutorial we will cover the step-by-step process of installing Visual Studio and Intel oneAPI, and then we will show you how to link these two software tools with the Abaqus software. We're going to specifically focus on linking Abaqus using FORTRAN. We'll go through this process thoroughly, ensuring each step is well explained. Following the setup and linking, we will do verification tests to ensure everything is working well. Finally, we will provide an example of writing a subroutine to validate that the linkage has been successfully established. This video was provided by Saman Hosseini, and he's going to show us how to connect Abaqus 2021-2023 with Intel oneAPI and Visual Studio. The first step is to install Microsoft Visual Studio software. To do this, we are using the latest available version at the time, which is the 2022 edition. I've also worked with other versions such as 2019, and they function perfectly. The following step is to install Intel oneAPI HPC, an Intel oneAPI based toolkit. For this purpose, I'll use the 2022 version, although more recent versions like the 2023 edition are also available. The order of installation doesn't matter. You can choose to install Intel oneAPI HPC first and then Intel oneAPI based toolkit, or you can do it the other way around. Both methods work equally well. In other tutorials, I've come across many users who prefer installing Intel oneAPI based toolkit before Intel oneAPI HPC. However, based on my testing, I found that it's perfectly acceptable to install either one before the other. Moving on, the next step involves installing Abaqus 2023 with the CAA API component. Afterward, we'll proceed to add and define vcbars64.bat path in the environment variables paths. This file is associated with Microsoft Visual Studio. The following file, relevant to the FORTRAN compiler and Intel oneAPI, is named vars.bat, and its path must be defined and added to the environment variables paths. This process is detailed in the video. Next, right-click on Abaqus CAE and Abaqus command, select Properties, and then you'll need to add a provided text to the target lines. So far, we've successfully established the link between Abaqus and FORTRAN. However, it's important to note that this link is only present in the shortcut of Abaqus CAE and Abaqus command. When you click on Abaqus file, you will not see this link in action. To address this issue, I've included a fourth section in this tutorial, which covers editing the batch file. There is a batch file, and you need to insert a specific text into it. Once this text is added, clicking on any Abaqus file will allow you to proceed with writing subroutines, and the subroutine linking will also be activated. The final step is the verification phase. After completing the verification, we will run an example of subroutines to confirm that the link is functioning. To initiate the Abaqus FORTRAN compiler linking process, start by searching for and identifying the vcbars64.bat file, which is associated with Microsoft Visual Studio software. This tutorial provides a comprehensive explanation on how to find and locate vcbars64.bat. Next, you should also locate the vars.bat file, and the tutorial will guide you on how to add its location to the environment variables. Following these steps, proceed to copy the highlighted text and paste it into the target line of the Abaqus command. The video provides a detailed explanation of how this text is generated. It's worth noting that a portion of this text represents the path where the vars.bat file is situated, while the remaining part is the pre-existing text with the Abaqus command. Similarly, for the Abaqus CAE shortcut, The initial section of the highlighted text should be copied and pasted into the target line of the Abaqus CAE shortcut. This process mirrors the previous one. The first part of this text represents the path for the vars.bat file, while the subsequent part is the pre-existing content within the Abaqus CAE shortcut. Now let me walk you through the process of creating these necessary texts. As mentioned earlier, the link has already been established, allowing you to write subroutines when you click on the shortcuts. In the final step, you should open the batch file of Abaqus CAE using a text editor, such as Notepad++ or Windows Notepad. Then, copy and paste the highlighted text that you see into that batch file. The video will provide a step-by-step explanation of how to generate these texts. It's important to note that the process of creating these texts may vary on different computers and can also differ based on versions of Microsoft Visual Studio, FORTRAN compiler, and Abaqus CAE that you're using. Given that the versions of the software you're using may differ from the ones I've mentioned, it's valuable to explain any distinction or variances between your software version and the one referenced in the tutorial. This helps ensure that the instructions remain relevant and applicable to your specific setup. An example of such a difference might be the presence of a folder named 2022.1.0 in my version, whereas your version could be labeled as 2023 or differently. It's important to note that such variations should not pose any issues. The fundamental principles and procedures remain consistent, regardless of the specific version number, ensuring that the work can proceed smoothly. In the verification process, the initial step involves opening the Abaqus command and then inputting the following text: ABQ 2023 info equals system. This command provides system information. If you're using a different version of Abaqus software, it's important to adjust the year in this text to match the year of the version you're using. This ensures compatibility with your specific software version. After entering this text, you will notice that it displays information about the Intel FORTRAN compiler, confirming that the link has been successfully established and is functioning. By clicking on the Abaqus verification shortcut, the software initiates a series of tests to verify the functionality of various Abaqus components. This includes testing the integration of subroutines. For example, it will indicate whether Abaqus standard has been successfully linked or not. And similarly for Abaqus explicit, this testing process helps ensure that all components are working correctly. In some cases where the links are not established correctly, you might observe that Abaqus standard has been linked successfully, while the Abaqus explicit has failed. However, by following the method I'm showing, both Abaqus standard and Abaqus explicit links will be established. To conclude, we will run an example that shows the linking of Abaqus with FORTRAN, and then another example showcasing the use of subroutines. This will provide confirmation that the link has been correctly established. As you can tell, I'm using the offline installer for Microsoft Visual Studio. So I simply double-click on the VS Setup exe file to start the installation process. You'll notice that there are various installation options available here. For example, in the Web and Cloud section, there are options related to Python development, but we don't need them for our purpose. However, in the Desktop and Mobile section, we only require two specific components from the options available. One is Desktop Development with C++, and the other is Net Desktop Development. However, we don't need mobile development with C++ or Universal Windows Platform development. We can skip installing the gaming section as it would be unnecessary. Also, there's no need to install the other toolsets section, including Linux, Office, data storage, and so on. We only need two options, .NET Desktop Development and Desktop Development with C++. These two options include Visual Basic and C++, which are sufficient for our needs. Therefore, we'll only check the checkboxes for these two options. Now that the installation has been successfully completed, There's nothing else we need to do. We can proceed to install the other components as necessary. In this phase, the installation of the Intel oneAPI base toolkit begins. The key focus here is to carefully select and pick the components that are both suitable and necessary for linking Abaqus and FORTRAN compiler. In this context, there are just two essential components: the Intel oneAPI DPC++ C++ compiler and the Intel oneAPI threading building blocks. These are the only ones necessary, and there won't be any issues if the other components are not installed. Now in this part, you have the flexibility to decide where you'd like to install the software. The reason for installing Microsoft Visual Studio before Intel oneAPI is that they can be smoothly integrated using this section. Now it's time to proceed with the installation of Intel oneAPI HPC. After running the setup file, you can continue with the installation process. In the component selection phase, choose only the Intel FORTRAN compiler and the Intel oneAPI C++ compiler, since these are the only essential components. If you had been paying attention, you would have noticed that I installed the Intel oneAPI base toolkit before installing the Intel oneAPI HPC, just like it's done in the other guides and tutorials. However, based on my experience, if you install the Intel oneAPI HPC toolkit before the Intel oneAPI base toolkit, there won't be any problem, and the link will still work. Now that we've completed the installation of Intel oneAPI and Microsoft Visual Studio, to locate the vcvars64.bat file, you simply need to follow the path I'm about to show you. As you follow this path, you may come across folders like Enterprise, VC, or Build that could assist you in locating the file. An alternative method to find this file is simply search for vcvars64.bat in the search bar, and it will show you its location. I use both of these methods because the path to the file can differ depending on the version of Windows on your device, so it's good to have options to cover different scenarios. For example, in this tutorial, I'm showing you on Windows 11, but you might be using Windows 10, which could result in different file paths. I'm teaching you all these methods so that regardless of the software or Windows version, you can easily find the file paths without encountering any issues. This ensures flexibility and ease of access. Now that you've located the file, simply right-click on it and then select Open File Location. As you can observe, the path we followed earlier and the path obtained through the file search are identical. There's no difference between them. You should copy this path and then open a text file to save it. This way, you'll have it ready to enter into the environment variables. Next, paste this path for future access. Now we'll repeat the same process for vars.bat file, which is associated with the Intel oneAPI software. The final folder where this file resides is named env. Now let's repeat the same procedure using the search bar to obtain the path, ensuring we have both ways covered. One important thing to note is that the version of Intel oneAPI I have installed might differ from the one on your computer. The version number, such as 2022.2, may vary on your system, and you can easily find it. You can access environment variables in two easy ways. First, simply search for environment variables in the Windows search bar. Alternatively, open this PC, right-click anywhere, choose Properties, and then click on Advanced System Setting. Both methods lead you to the same place where you can manage system variables. The paths you've copied can be pasted in both user variables and system variables. If you paste it in system variables, it will apply to all users. Now double-click on Path and copy the file's path saved in the text file. Click on New, and then paste the path into the newly created field. Repeat the same process with the path of the second file, vars.bat. and paste the copied path into a new field that you create. This is how we set paths for two important files. You can easily locate the shortcut for Abaqus or Abaqus CAE by searching for it. Once found, you can easily access the software's installation folder by right-clicking on the shortcut and selecting Open File Location. Next, right-click on Abaqus command and select Properties. Here, you'll find the target line, which should be replaced with the text from the text file. As you can see, the beginning of this text is the same as the path of the vars.bat file we located earlier. After entering the path of the vars.bat, you should also include Intel 64, followed by VS and the year version, which in this case is VS 2022. Then add an AND symbol and append the initial target that was already in the bar. To modify the text in the Abaqus CAE target, use the path of the vars.bat file once more, followed by Intel 64, VS, and the Microsoft Visual Studio version for the year. Then add the AND symbol and include the initial target that was originally in the bar, which was the initial target for the Abaqus CAE. At this point, the link between Abaqus and FORTRAN has been established. But it's important to note that this link has only been set up for the Abaqus CAE and Abaqus command shortcuts. If you wish to open an Abaqus file, the link may not work as expected for those specific files. That's why I recommend completing this last step to establish the link connection for opening Abaqus files as well. To accomplish this, navigate to the C drive and access the Simulia folder. Inside, locate ABQ 2023 batch file and add the required text inside it. To do this, you have two options. You can either open it in Notepad++ and edit it there, or simply click on Edit to modify it using the default Windows text editor. In this case, you'll be using Notepad++, but it's worth noting that there's no significant difference between using this method or the other. To start, insert a new line between the two existing lines by pressing the Enter key. In this text file, you'll notice that the text consists of call, followed by the path to the vars.bat file, and then Intel 64 VS, followed by the year version of Microsoft Visual Studio. You can create this text file for your own system by following these steps. Simply copy the provided text and paste it into the new line you've inserted. After saving this file, you'll find that every Abaqus file will be properly linked, allowing you to easily use subroutines. At this point, you've seen a step-by-step and thorough guide on how to establish a link between Abaqus and FORTRAN. One important thing to note is that in some linking methods, the link might become disabled after restarting the system, requiring you to re-establish it. However, the linking method I've shown you here is stable and the link will remain consistently. Earlier, I mentioned a few methods to ensure that the link between Abaqus and FORTRAN has been successfully established. One of these methods is using the Abaqus command. Once Abaqus command is launched, you only need to enter the following command: Abaqus info equals system. As you can see, both C++ and FORTRAN compilers have been successfully linked to Abaqus. When you launch Abaqus verification, you can easily check the connection status between Abaqus Standard and Abaqus Explicit with FORTRAN, and it will be displayed automatically. I recommend paying attention to this aspect because sometimes the standard solver may establish a link with FORTRAN successfully, but the explicit solver may encounter issues in doing so. By using this method, you can conveniently check the status of both connections. To ensure the Abaqus link with FORTRAN is working properly, I'll provide you with an example written in FORTRAN. In this part, you can set the number of subroutines, and you can also specify the number of processors, which can help the program run more efficiently and faster. You have the option to skip entering any values here and simply run the program without any issues. Now, this is the file containing the written code. There are a few fundamental rules in the FORTRAN that must be followed when writing a subroutine, and I will discuss these rules in another video. As you can see, the program is currently running. The initial message indicating success confirms that the link has been correctly established. Following 3 successful messages, it indicates that the program has run perfectly and is now completed. Here you can observe the use of subroutine writing. For instance, defining temperature flux can be achieved in Abaqus, but this flux is predetermined and cannot change during the simulation. To enable this temperature flux to vary, subroutine writing is employed in applications such as 3D printing, welding, and more. Thank you for joining me throughout this video. If you want to test your link, I've added the subroutine file for testing. If you have any questions about establishing a link between Abaqus and FORTRAN or writing subroutines, you can visit the Hyperlyceum website. Thank you and see you in the next tutorial. Let's introduce Saman Hosseini, a member of the Hyperlyceum team. Saman, a PhD student, brings over 6 years of extensive experience in Abaqus with more than 400 successfully completed projects, including fracture mechanics, composites, additive manufacturing, biomechanics, and beyond. He leverages advanced simulation solutions coupled with Python scripting and FORTRAN subroutines. Saman offers free online consultation sessions tailored to graduate students, professors, and industry experts seeking to learn modeling techniques. With over 200 hours of tutorials and having mentored over 100 students, he is dedicated to helping you with your research, education, and industry-related projects. Contact Saman today to schedule your free consultation, discuss your project, and confidently tackle its challenges.